So good morning to all of you. I welcome you to this session on big data analytics. In today's session, we are going to learn about Apache Pig, the various data types and operators therein, about the grunt shell and its invocation, about the execution modes of Pig, some basic utility commands, how we can analyze the data stored in HDFS using Pig, and importantly, the load, store, and the dump operators in Pig. That would be the interesting part in today's lecture. So we learned about Pig, like what is Apache Pig, why do we need it, and then the various things about MapReduce, the architecture of Pig. This we discussed in our previous discussion. Also, the Pig installation was there. Then the MapReduce basics and the MapReduce Hello World program, the word count program, which we executed on this text file, right? And about the map and the shuffle and the reduce phase. All right. So let's now continue our discussion on Pig Latin, which is known as a parallel data flow language. Okay. The emphasis is on the word data flow. Okay. That means it allows users to describe how data from one or more inputs should be read, processed, and then stored to one or more outputs in parallel. Okay, and these data flows can be simple or complex. Okay, so we can have two types of data flows. Either we can have simple data flows or we can have complex workflows also. Okay, we'll discuss what these simple and linear and complex workflows mean. And mathematically, you understand that your Pig Latin script describes a directed acyclic graph where the edges are the data flows and the nodes are the operators that process the data. Okay, kindly keep this thing in mind while you're working with Pig. Okay, and one more thing, this Pig Latin is different from your traditional programming languages that you people have been working with or working with, in the past as well as in present, right? See the differences. There are no if statements or for loops in Pig Latin. Simply because it's a data flow language, okay, there are no if statements and no for loops. So that's the difference from your traditional C, C++, Java, Python languages. Okay, and the reason is simply that the traditional languages, they describe something known as control flow. Okay, whereas Pig Latin focuses on data flow. Important point of differentiation between Pig Latin and the traditional procedural or OOPS languages that you people have been dealing with. Now, let's see where all Pig is used. So I've taken up some Pig use cases. Okay. Now it can be used in every business. Okay. Some of the possible use cases are, it is a widely used big data processing technology. So obviously you understand that Pig is a big data analytics processing technology and works on Hadoop. Okay, and more than 60% of the Hadoop jobs are Pig jobs at Yahoo. Okay, so one use case we see that at Yahoo they are using 60% of the jobs, the Hadoop jobs are the Pig jobs. Then Twitter is using Pig for log analysis, okay, for sentiment analysis, and for the mining of tweet data. Okay, mining means we are trying to mine or extract important information from the vast amount of data present on Twitter. And one important aspect of Twitter is to analyze the sentiment, the mood of the people. Okay, so Pig is used extensively for that. Then PayPal is using Pig to analyze its transaction data and for fraud detection. And many companies use Pig for analysis of its web logs. Right? So these are some of the Pig use cases. You can see that every business can benefit out of using Pig at their workplace. Now Pig is based on these 4 founding principles that we say is the philosophy of Pig. Okay, we say that Pig is based on this philosophy. Okay, and with these points about philosophy, users can get a broad helicopter view of the technology. That is what this technology is all about. So 4 points are there. First philosophical point about Pig is pigs eat anything. Second is pigs live anywhere. Next, pigs are domestic animals. And then pigs fly. Okay. So what do we mean by pigs eat anything? That means pig can handle any type of data, structured data, semi-structured data, or even unstructured data. Okay, it can handle any type of data. That's why we say the philosophy, pigs eat anything. Then second point is pigs live anywhere. So that means the data that pig analyzes, it can stay anywhere. It could be on your local file system. It could be on your distributed file system, right? So pigs live anywhere would mean that the data can reside anywhere, either in the local file system or in the distributed file system. Next, pigs are domestic animals. That means pig is a user-friendly language. Okay, you can use it to design your own functions, right? And last, the important point, pigs fly means that even though the speed of the pig is not as very fast as compared to some other languages, but even then it is capable of computing at very high speeds. Okay, so these are the 4 points of pig philosophy, right? Then let's talk about the data types in pig. So two types are there: simple and complex. Okay, simple and complex. And in simple data type, since it is based on Java, so you can see the familiar Java data types: int, which is a 4-byte, long 8-byte, float 4-byte, double 8-byte, and like all these Java data types are there. You can have a look. There is a data type byte array also, okay, which is to use to handle the binary data. And one important data for your analysis of data sets is your date time, right? Based on date and time. So we'll be working, extensively on this data type. This should be good to work with this data type, right? So this is the summary of simple data types in pig. Next is the complex data types, right? So we have 3 in this category: a map, a tuple, and a bag. Okay, let's see what they look like. Map is like a key value pair. Okay, it's like a key value pair. You can see an example here: 100 hash Apache pig. So a key and a value, right? And tuple is like you see anything enclosed in parentheses. So this is like 2 values enclosed in parentheses. We'll be using this a lot in pig. And we can have a collection of tuples like this, okay, which we call a bag. So we'll be working with all these data types as we progress through our pig learning. Then there are other operators, like in traditional languages, we have the relational operators. Okay, you can see the relational operators. So apart from the 6 usual relational operators, okay, or the comparison operators, we have a matches operator also. Okay, so we'll see how we can use this matches operator. Then the Boolean operators are there: and, or, not. Okay, then we have identifiers. Okay, so identifier could be the name of fields, of relations, of aliases, of variables, and so on. So we'll be working a lot with this term relations in our Apache pig. Okay, now identifiers, they begin with an alphabet, can be followed by letters, numbers, and underscores. Just like any other traditional language, you can have these 3 things in your identifier name. So identifier could be the name of a field, of a variable, of relations, and so on. You can see the correct names here. You can see the incorrect names. So we suggest here that underscore should not be used as a beginning character. The identifier should always begin with an alphabet. Okay. And then to find the schema of a relation, you understand the schema, right? If you want to see what is there in a relation, you can use the describe keyword. Describe followed by the relation name, right? Now next is the grunt shell in pig. Okay, so we have already started working with grunt shell. And grunt shell, it can be used for submitting pig Latin scripts. That means the code that you have written to analyze the data, it could be submitted to pig Latin and can be executed there. For controlling the various jobs which are going currently in your environment, Hadoop environment, and it gives you an access to use the file systems, the local as well as the HDFS. Okay, so this is all what you can use grunt shell for, right? So obviously the next important thing is how to start or invoke the grunt shell, right? So grunt shell can be invoked in the following 4 modes. Okay, read this as Tez_local. It's written here in this image as Tez-local. should be read as Tez underscore local. So we'll be working mostly with two. If you have Tez installed, then we can have these two also, Tez and Tez underscore local. But our focus would be on local and MapReduce mode. So how to invoke the grunt shell? You write pig, then -x, and then the mode. Okay, any of these four modes can be given, right? -x stands for execution type. So you are suggesting execute pig in the, so mode, if you write local, in the local mode. If you write MapReduce, in the MapReduce mode. Okay. If you invoke, pig without any parameters, then it will be taking the default mode, that is the MapReduce mode. So MapReduce is the default mode for pig, right? You can take a screenshot of this. Okay, let's now move to the terminal. Okay, and I've already started the distributed file system services. They are running. So let me invoke pig, say, first of all, in the local mode. What do we mean by this? By local mode, we mean that we can access the files from the local mode. Okay, so we use this mode for experimental purposes, for running our, checking our operators and doing small operations, not working with huge files. Usually we work with the local mode when we are interested in testing the operators or functions, right? So let's use this clear. And to come out of it, okay, to come out of the grunt shell, right now I invoke the grunt shell in the local mode, so I can access the files in local mode. To come out of it, I should either write quit, okay, like I've done here. It will come to the bash shell. And other way is you can press Control D to come out of it. I'm pressing Control D, so it will come to the bash shell. Two ways of quitting the grunt shell is to type quit, either to type quit or to simply press the key combination Control and D. Okay, so if I invoke pig without any parameters, it is opened in the MapReduce mode, and it is indicated here. You can see on screen, it has picked MapReduce as the execution type, meaning which that now we'll be working with the files in our distributed file system. Okay, so just see the important difference between local and MapReduce. We can also see if we can go with Tej. Okay, let's come here. Let's start pig in. If Tej is installed, it will pick it up in Tej mode. Let's see what it says. Okay, so Tej environment is also there. Okay, and let's try Tej local now. Let's try this Tej underscore local, whether it is present or not. We'll see. So you can see all the four modes are there. Okay, but like in my discussions, I'll be focusing mainly on this local and MapReduce mode. Okay, so let's come out of it here. Right, let's switch to our presentation. Now to work with the, once you started working in the grunt shell, okay, then if at times you need to run the bash shell commands, okay, or you need to work with some Hadoop commands, HDFS commands, while you are there in the grunt shell, then you can take the help of these two commands, fs and sh. Okay, so if you need to run the bash shell commands, start the command with sh. Okay, and if you want to work with your HDFS commands, start with fs. This is while you are in grunt shell. Okay, so the description is there. Just start with fs and write your HDFS commands as usual. Okay, similarly write sh and write your bash shell commands like usual. So let's see some examples for this. Let's say I want to list the files. Okay, so if I write lsc, what happens? Okay, right now we are in bash, so let's first go to our grunt shell. Okay, and write here ls. Okay, it will give you a different, like you are in the MapReduce mode, so it is listing the files from your distributed file systems, but in a different way. So you can use sh and then ls, then it will list all your files in the local file system, right? You can go in for a long listing also, right? Similarly, if you want to run the distributed file system commands, HDFS commands, start them with fs followed by the command and whatever parameters you want to do. So I want to see the files in the user folder in the distributed file system. Just see that the command is beginning with fs, okay, which stands for file system. And the execution of commands here would be very fast. Okay, you can see that. Suppose I transfer a file, say fs hyphen put say examples.desktop, this file, suppose I'm transferring to the user folder. Okay, this file is not there currently. If I transfer it, just see the speed of execution. It's done. Okay, the speed is fast while you are executing your commands using the fs option in the grunt shell, right? Then next is some utility commands. You can use the help command. It would print a list of pig commands or properties with a short description and syntax. Okay, let's try that. Let's try this. Let's write help here. Okay, so you can see it has displayed the commands which are there. Okay, some are categorized as diagnostic commands like describe, explain. Then utility commands are there, execute, run, sh we just work with. Okay, right? So all these commands, you can see the history command is there. We'll discuss these commands one by one. You can see quit command also to quit the grunt shell. Okay, so help can be taken up to discuss the basic utility commands, the diagnostic commands in the environment. Okay, you can see fs also here, your file system command. So it is equivalent to Hadoop DFS command. Okay, all right. Then next, let us see about the history command. Okay, so your history command is going to display previously used commands in the grunt shell. Okay, so and you can also rerun these commands. Okay, they are numbered by default. If you don't want to see the numbering, use the -n option. Okay, to navigate the list of commands, use the up arrow and down arrow. Right. So let's see how we can use the history command here in our grunt shell. I'm writing here history. Okay, so now, right now we have not executed any Apache pig command. Okay, so I'll come to history in some time. While I start using some commands in Apache pig, I'll be coming to the history command to show its working, right? Okay. Next is quit, kill, and set. I'm taking up these commands because they are not of much significance for your working. Yeah, in a collective, in a cluster environment, in an organization, it would be important. Like quit is to quit the grunt shell, right? And you can also use Control+D. And kill is to kill some running process. A bot or kill is the same. So you need to write kill and some job ID. So I don't think we can use this. We may try, but it's not of use for us. Okay. And the set command, can make some environment setting both for pig and Hadoop. For example, if you give this command set default parallel 20, would set the number of reducers as 20, right? Okay. So what are reducers? We have already seen, but then we are not going to go into much detail about MapReduce. So you can just see how the usage of the set command, set default underscore parallel space 20 would mean to set the number of reducers to 20. Then we have the execute command, right? You can see the syntax of execute command. So if you need to execute your script, your pig Latin script written in some file, okay? So a script would be a collection of commands stored in some file. So you can execute, you can run them using the execute command, which takes some options also, -param and -param underscore file, where param stands for parameter. Okay, so any extra parameters that you want to specify, you can give it with the help of param. And if you want to specify the parameters in a file, then you can use -param underscore file. We'll see how we can work with these commands. Don't look too much into them right now. Similar to execute command is the run command. Okay, it is similar. The difference between these two is, kindly note that the run commands, they become a part of the history of grunt shell environment. Like if you run 5 commands in run, they become a part of the history, right? Okay, and they work with the same parameters that you have in execute. The only difference is that run commands, they become a part of the history, but if you use execute command, they are not a part of the history. They are not stored in history. Okay, so if you don't want to show what commands you are running to other people, right, you can use execute, okay, instead of run. Otherwise the functionality is the same. The difference I've told you, that execute commands are not, they don't become a part of the history, whereas run command, it becomes part of the history. How, we will see soon. Okay, next is running the pig Latin code. Okay, so we have just seen that we can use run and execute in the grunt shell to execute our pig Latin code, right? We can also use pig-e and pig-f commands that we can use in our bash shell. Instead of going to grunt shell, we can use them in the bash shell. Okay, but before we actually see these, codes, pig Latin codes running, we must understand how to write the code. Okay, so I'll be focusing on that, thing now, that how to run the, how to write the code, and then we'll see all these running modes, the execution modes. So let's discuss about, the operators which can help us in analyzing the data. Okay, in this category, the first operator is the load operator. Okay, so load operator, you see, it loads the data from the source system, and the load statement, it consists of two parts divided by the equal to operator. Okay, so we have an equal to operator. On its left, we write the name of the relation where we want to store the data. Okay, we are going to load the data, so it would be loaded up into a relation. So on the left of equal to, we write the relation name, and on the right hand side, we would be writing the load operator followed by some parameters. Okay, so you can see the syntax of load operator on screen now, right? We have a relation name on the left, then an equal to sign, then the operator load, then the file which is to be loaded. You need to mention the path here. So if you're using a local file system, your grunt shell in local file system, you can use the local file system path here. Otherwise, you can use the HDFS path. Okay, then you can specify some function using function. Okay, so function would specify what type of file we are handling, right? So by default, the function is pig storage. Okay, by default, the function is pig storage, and which takes an argument which would tell what is the separator in the file. Okay, there are other functions also: bin storage, JSON loader, text loader. Okay, we'll be focusing mainly on pig storage. We can work with these other loaders also, right? And then you see, in pig, you may work with a schema, you may not work with a schema. Okay, if you want to specify a schema for your data on the spot while you are loading it, then you can use the as keyword and followed by the schema. Okay, and the schema would look like this: the name of the column 1, its data type; name of the column 2, its data type, and so on. Okay, and if you don't specify, the schema, then the columns can be referred to as the first column as $1, the second as $2, and so on. Okay, so let's now see this working. We'll take some time to describe this in detail. Okay, what I'll do is I'll first create a file which we need to load. Okay, I'm going to create it now. I'm in grunt shell using sh to use the gedit operator, and making a file w1.txt. Kindly keep on noting now. And in this file, I will write some data. Okay, I'll write some data, say like this, say 101 Ramesh, say, so some employee is employee code, name and salary, right? Something like this. And say 35,000, 103 Kabir, say 55,000. Let's take these three records. Let me save it and let me come out of it, right? I won't be taking any questions right now. Okay, so don't raise your hands. And then we can also display the contents of this file. Okay, this is the file that we have just created. We see the contents of this file w1.txt. I'll be loading this file now using the load operator, right? And we are in, let's see which mode we are in. Let's go in for the local mode to make things simple in the beginning. I'm starting pig in the local mode, so I'll be picking up the files from my local file system, right? So we have started pig, the grunt shell is there, right? And we just saw this file w12.txt, w13 I suppose. I missed that file, I suppose. Let's see it. W1, okay. So this is the file that we just created. I will load this file using the load operator. So it is in my local file system, okay? Right? So let's see how to use this. I'll take the the relation name as M, and I will write here load. In single quotes, I will write the file name. Okay. First, I'll go simply just like this. So when I don't specify any load function or any schema, then it will take the file as the pig storage file and separated by a space or a tab. It is taken up as a tab separated file. Kindly note this thing, okay? And each command is executed by ending it with the semicolon. So I am loading the file w1.txt into the relation M, okay? I'm running it now. So it is loaded, right? Some messages are there. I told you don't bother about them. You can remove these messages also by doing some R&D. That's not difficult, okay? Then nothing happens with the load. It is simply, the data is loaded into the relation M. Then after that, you can have two actions, okay? Either you can display this data on the screen. That is done with the help of the dump operator, or you can store this data into a file. Okay, you can store this data into a file using the store command. Okay, let's first see the dump. So you need to write dump followed by the relation name, that is M. Dump command, you may end it with a semicolon, you may not end it with a semicolon. Remember this thing. One more thing, the dump command does not become a part of the history. Remember this thing also. Dump command does not become a part of the history. So right now, how many commands we have written? We have written the load command. We have written the dump command. We also wrote the sh command, but it also does not become a part of the history. Okay. So I'm going to run the history command now. Okay. You can see there is only one command, the load command. Okay. I told you commands beginning with sh or fs are not included in history, and the commands like dump, dump operator, it is not a part of the history, and it may not end with a semicolon. So you can write dump like this also, without semicolon also, with semicolon also. So you can see that this relation is shown here. You can see here 101 Ramesh this. Now, if I want to see, we have a data now, we are visualizing this data. There is no schema, so I'm visualizing it as three fields. The first field, then a tab or a space, second field, and then a third field. Okay, remember this thing. Now let me load this load statement. I'll vary it like this now. Keep on noting, please. I'm using it like this. Okay, it's the same. So whatever load statement I wrote as first, and now this one, this is the same. Okay. I can just make it more better like this. Okay. So just see this load statement here. I'm loading and I'm mentioning the pig storage. I'm specifying that the file which is being loaded is separated by a tab or a space, right? And even if I don't write it, it takes it in the same way, right? If you dump it, obviously, again, you'll get the same output. I hope this loading is clear. Okay. Then if I want to take a CSV file, a comma separated values file, I'm stressing this point, kindly note it down. If I want to specify it as a comma separated values file, what difference will it make? Okay. Now let's see. I'm taking one operator now, which I intend to discuss in my future discussions with you. But just for the sake of clarity, I'm using it here. So I can take a relation name AA, and then I can use a for each operator. Okay. So for each M, I'm writing here, generate, say, $1. Okay. I'm using this. See this, you can note it down. So this is, if you want to display specific parts of your data, you can use a for each. So this is similar to, I'll mention, this is similar to your select column name from table name. Okay, this for each that I've written on screen, this is similar to your select column name from table name. I'm mentioning some columns which I want to display. I don't want to display all these three things, 101 Ramesh, 40,000. No. Okay, so let's now dump AA and let's see what it gives us. So it does not give us anything, right? It has not displayed anything to us. Okay, so let's use $0 here. Okay, and let's dump it now. So it is taking this up as there is no tab. Okay, there is no tab here. So it is taking this as one field, 101 Ramesh 40,000, and that field is given by $0. So in our projection, $0 is the first field, $1 is the second field, and so on. Okay, so I'm going to modify this file now. I'm taking a bit too long on this just to make things clear to you while you work with your files. I'm going to edit this file again now. Okay, see the change now. I'm going to change it. I took it as a space deliberately. Now I will remove the space and make it a tab. Okay, a tab. Kindly note what I'm doing. Otherwise, when you analyze data, your files would be specified automatically. When the file is given to you, it would, like we are creating it on our own. So now it is a tab separated file, right? Okay, I'll save it. I'll close it. Once again, I will load it. I'm loading it. And even if I don't mention a tab here, I'll load it the simple way. Kindly note, all of you. I've loaded it. Now let me dump it. There won't be any change in dump. Okay, it will show the same thing. But when you project now, when you project, you can see now there are three things now. Can you see the difference in output here? Like if you use a tab, which is the default, if we can see the previous screen, see here it was the space. There was no tab. So this was being taken up as one field. Now we have got three fields because the separator is tab. And now if you use this statement, okay, then you will see 101, 102, and 103 as the output. So I hope you know now that the file type is very important. You must be clear while you are specifying the file type. Similarly, I can extend this to completely mention all the columns that I wish. Okay, so now it will display two columns, 101. I displayed using this. Okay, so for each operator we'll be discussing, we'll be using it a lot. So it is used for projecting specific columns, and if some condition is there, then specific rows also. Okay, I hope this point is taken. And now the second point, that if I load the file, if using an extended way here, if I use this, even then it's the same. Okay, even then it's the same. And if I dump the relation M, it will show the same display. If I use this, okay, it will show the same output. Kindly note. Okay, I hope it's clear. Now let's change our file. Okay, let's take another type of file. Now let me separate them by commas. Okay, let me separate them by commas. Now this is a CSV file, a comma separated values file. Right? I'm saving it. Now this file w1.txt is a comma separated value file. I'll again check it so that you can understand that if I load it like this, okay, right? So if you dump it now, see on screen, if you have loaded this file, remember w1.txt is now a comma separated. The values are separated by commas, but you are not mentioning this in your load statement. When you write your load statement like this, it means that you are expecting a tab separated file. Since there are no tabs, so all the three things would be taken up as one field. How? We will see. Let's dump. You see these three things, right? Let's now do the projection. Or let's do the projection like a $1 here. Okay. And let's dump it. So there is no $1 here. Do you see? Because if I dump the relation for your reference, it is having three values separated by commas. In your file, they are separated by commas. So when you read this, when you load this, and you don't mention any, delimiter here, like this, when you load it like this, it assumes it w1.txt as a tab separated file. If there are no tabs in your file, that means this entry 101 Ramesh 40,000 is one field. Okay, so that is why when you do like this, when you generate something like this, say $1, there is no $1 here. There's only one field $0. Okay, if you dump it, you will see null, nothing. Okay, now how to make it a comma, how to read it in a comma separated values file? You can load it like this using pig storage. You can use it using pig storage and mention it like this. Okay, use it and mention it like this, right? So if I mention it like this, now it would read w1.txt as a comma separated values file. So now if you project with this like $1, it will show you the names. You can see that. I think the point is clear that by default, the separator is tab, even if you don't mention it using function clause like here. Okay. And if you don't specify any schema, then by default, the first field is $0, the second field is $1, and so on. And what about the data types now? We took three values, 101, Ramesh, and salary, 102, Seema, and salary, like this. Okay. So if you don't mention any schema, then the default data type in pig is the byte array. And how we can see it? We can use this describe statement to do that. Describe, say M, describe relation name, right? So you can see the schema is unknown. Right now, there is no schema. Okay. So let's mention a schema, because right now we have not given any schema. So there is no schema. Let me give a simple schema. Okay. Like this, as say, M code, E name, salary. Okay. I've not given any data types. Remember, I've just mentioned a schema. If I don't mention a schema, the field names are taken up, or the column names are taken up as $0, $1, and so on. Now the field names can be taken up as M code, E name, and salary, as well as $0, $1. That would stay automatically. Okay. So what I'm suggesting here, kindly look on screen. If I just take this and I use $1 again, okay, there's no problem with this. Even though I've given a schema, okay, it will still display this. And I can use E name here also now. Okay, so this will work fine. Okay, let's see a combination if it is possible. Okay, let's see if we can go with $0, E name. Let's see if it is fine with this. It is fine, right? So you can have a combination of the schema or the default name, schema name for fields, that is $0, $1, and so on. Now let's now have a look at the schema of this relation, describe M. So now you will see the default data type is byte array. I have not mentioned any data type for my M code, E name, salary. By default, it takes byte array. So see the intelligence of Pig here, that it is taking them automatically. And when you use it in some computation, okay, it will also do that. Okay, if you use some totaling, multiplying, it will do that. We'll see it in our future sessions. So I think this load statement is clear now in its totality. One more thing is left. Let me specify that also. I can specify the data types also here. So maybe I can specify this as int, use a colon, this as a character, so char array, and this maybe as float or double, right? So this is full now statement in front of you. The load statement using Pig storage function, comma as the separator, and the schema given by the column names and the data types. Okay, and if you display this now, the describe, now you can see that this is the complete description of your relation. So you can see how it is explained, the relation. You have the emp relation here, and the column names, the field names, and the data types are there. Okay. So this is one complete. You can see it on screen. I'll just clear the screen for you guys. This is one complete load statement. Okay, I hope you understood it properly. That is the first part. Dump you have seen, right? Dump you have seen is used to display whatever is there in the relation that is dumped or displayed on the screen. Okay, let's now go to history and see how much we have added to history. See the commands now. So whatever commands you wrote, they become a part of the history. If you don't want to see the line numbers, you can go like this. Okay, dump command is not a part of the history. Commands beginning with sh are not a part of the history. Beginning with fs are not a part of the history, right? So we have understood load and dump. Okay, next let us understand the store operator. Okay, I am going to work with the store operator for you now. Store would store your data in some file. Okay, so use it like this. Store m into, okay, some file name enclosed in single quotes. Okay, so maybe you can mention, say, Ravi12. Okay, this is the name that you are specifying. You specify a name in your store command, okay, after the into clause, and specify it in single quotes. Okay, and let's do it like this for the first time. Store m into Ravi12. So what happens is, once you do it, a folder with the name of Ravi12 is created in your local file system, since you are in the local mode. And within that folder, there would be multiple files, at least two files. One would be a file with the name as _success, which would be suggesting that storage is successful. And the second would be a part file, whether a part M for mappers or a part R for reducers. So if mappers and reducers both are being used in your analysis, then it would be a part R file. But normally when you are storing it simply, then it would be a part M file. Okay, so you can see the store command. You can read here, successfully read 3 records from w1.txt, successfully stored 3 records in home HD user Ravi12 folder. Total records written 3. So description is there. You can also see some job, DAG also. You understand, we studied DAG, directed acyclic graph. Okay, but you cannot see it there and it's working. So just for the theoretical purpose, it's there. And let's now go to our local file system. I'll just come out of this shell right now. Okay, I'm out of this into the bash shell, and let me just list the files. You see a Ravi directory here somewhere. Can you see the Ravi folder here, Ravi12? If you go to this folder, okay, you will see the two files that I'm talking of, the _success file, okay, and the part file. This part file contains your data. You can display that data. You can write like this. So you see the data is there. See the 40,000.0 now because you took it as a float. And see that by default it is tab separated because you didn't mention anything while storing the file. Okay, understood? Let's now go back to our grunt shell. Okay, let's go back to grunt shell and again store the contents of this file. Now you see this is lost. Whatever we had is lost. So if you say try to write this dump emp, okay, there is no emp now. That is lost. Okay, that relation is lost. It's not so. It is for the current session, right? So again, let's load it fast. In a fast way, we can load like this. Load, the file name was w1.txt, right? Using, you can write pig, and then you can use tab to complete things. Okay, this is a comma separated file. And then some schema can be written here. We wrote this. You may write, take any names. I'm taking this, and the data types you can see, right? And then I can take salary and float I have taken here, right? So once I've loaded this file, then if you dump it again, you get to see the data, right? You're seeing the data here, all the 3 rows. Let's check, like using pig storage as this. Let's see what is the problem. So when we use the store command and we don't specify any separator in our storage, it is taken up as a tab separated file. Now let's suppose that I want to store this emp relation. Let me first dump it to see whether it is there or not. So I have the emp relation here. Okay, and let me store it now. Store emp into, I can give some name, Ravi 45. This would be the name of the folder in which the storage would be done. And then I can specify a using clause. Okay, using pig storage, and then I can mention a comma here. Now when the file is written, then it would be separated by a comma. Okay, so we just finish it here. We go to our bash shell, and let's go to Ravi 45 folder. See the files. You can see the files again, and display the part file. You can see now it is separated by commas. Okay, so store command, whatever way you want to store your data, you can do it with store command. And store and dump, okay, they don't require any operator, any relation name on their left. These are the 2 operators in pig which don't require a relation name on its left, store and dump, right? So kindly remember this thing, store and dump don't require a relation name on the left. So we have discussed the load operator, the dump operator, and the store operator, right? Yeah. So let's now see the the working of the run and execute commands. We have learned how to load, store, and dump data. Let's now see the working of the run and execute commands, right? So what I can do here is I can create a file, a script file, and maybe I can give it the name as v22. I can give it the extension .pig, but it is not mandatory. Like, it is not mandatory to mention the pig scripts in a .pig file, right? So I'm going to create this file. I write the first command as, say, emp equal to load. The file name was what was that? w1.txt, right? w1.txt using pig storage as comma, as I can mention the full schema now, say emp number colon int, then ename I can specify as a char array, and salary I can specify as a float. This is my load statement. Okay, then I can have a dump statement. Okay, then I can have a store statement. Store emp into, kindly note whatever you feel is relevant. This is important. Store emp into, I can write here, say Ajay 99, right? I think that's okay. So this is my script. These 3 commands I want to execute. I put them in a file v22.pig, I will store this file. Okay. Then I'll start the pig in the local mode. I start the pig in the local mode. Okay. And I told you we can use run and execute commands. Let's first see the status of history command. Okay. Nothing is there in the history. Let me use execute to execute this file. I think v22.pig, right? So when I'm using execute, then whatever commands are written in v22.pig file, they would be executed one after the other. Okay. And you will finally, you will see the output, like midway, you will see the output. Then you will see the storage function running. Okay. So let's run it. You can see the same things now. I'll scroll the screen to show you the things, right? Let's go up here. Yeah, you see, first the load is there, then the dump is there. Okay, this is the dump part. Okay, but no command is written. You see, nothing. You know, the command starts from here, execute here. Okay, once you execute, no load statement appears on screen. Can you see? So when you use execute, the commands are not a part of the history, right? And obviously the store function has also done its task, and you can see here the output of the store. It has stored the 3 records in Ajay99 folder, right? Fine. This is when you do use it with the execute command. Now let's see the history command. Nothing there because commands in execute are not a part of the history. Now let's do it with run. The same thing. Run v22.pig. Okay, the same thing will happen now, but the commands would be a part of the history. There's some problem. Okay, you see, when you use a store command and you mention a directory name which already exists, it gives you an error. You need to change this directory name. I hope you've understood the problem. Two commands have executed, load and dump. The store command could not run because Ajay99 is already there. So obviously I need to edit that part of my file, v22.pig, right? I'll edit it so that I give a different folder name so that it does not clash with Ajay99 folder. So this is the problem here. I'll give it as Ajay999. I hope you picked up the problem here, all of you. Now if I use run, see the commands have come in the history. Can you see? When I used run, okay, and if I use history, both the commands load and store, dump is never a part of the history, right? Again, let me run using the run command. Okay, so you'll see the output now, right? And if you see the history, let's see the history now. So there are 4 commands: emp store. You can see that, right? So I think the differentiation between them is clear. You can go to your bash shell, right? You can go to your bash shell and go to Ajay99 folder and see the results. Obviously, that should not be a problem. You can see this. Again, you can go to one step back like this and go to Ajay999 folder. Let's see if it works. Yeah, doesn't go to Ajay999. Okay. Yeah, and then you can display the part file here. It's the same. So both the commands are working with run and execute, but commands in execute are not a part of the history. Commands, when you run them in using the run, then they are a part of the history. Okay. So I think you've understood all the concepts today. In my next class with you, I'll be discussing about the other ways to execute pig scripts, and we'll be discussing some more pig operators. So till then, thank you very much.